Hello friends, welcome to the Thrust of Curiosity. Today I am going to show you one interesting platform where you can learn physics concept without any stress, or obviously we are going to have some fun through this website. So you have to type PhET simulation, or you can also type PhET Colorado simulation. So if you type this, you will get this website, and let's click on this. So this website is developed by University of Colorado. Here what we have interactive simulations where we can change some few things and we will get different result. Through this we will learn physics concept. So it is like a game. So those students who play more games, they can do this and they will learn new things along with the fun. So I'm going to here in the simulation tab. There are various subjects, but I'm going to select physics. Basically this website was developed to learn physics concepts, but there are few more concepts which are developed later on. Also you can see there are some concepts common in between physics and chemistry and physics and maths. So you can see here there are total 56 simulations under physics tab, and you can see here there are various interesting simulations. Okay, so today we are going through one of the simulation, and you might have seen one of my videos in which I have used this charges and fields, and I have also used color vision in some of the videos, but I am planning to show you how each simulation is going to work. So today I am going to show you one simple simulation that is based on the density. So I will click on this. So just you have to click on the play button, and you can do this on your mobile phones also. So let's go to intro. Now here what we are going to see is we have this mass, and we have this part is nothing but the volume. Suppose if I drag this, so you can see total volume is 105 liter. Okay, so if I release this, or if I remove this, you can see the volume of this water is 100 liters. So if I drop this, then this volume is going to change. This is going to change because this much volume is added to the liquid. So this much wood is synced in the, you can see here the material, name of material is here. So I can change the material. Let's say I am going to put ice. Here we have the mass, so we can change the mass. So if I increase the mass, you can see volume is also going to increase. So you can here check about the density tab. Okay, so mass, and this is the density of that particular ice. So if I dip this completely, you can see 100 plus 9.25. okay, so if I obviously if I change this, then my volume is also going to change. If I change the mass, if I reduce the mass, volume is also going to reduce. So if I change the material, you can see this brick has more mass but less density. So if I increase this, obviously everything is under the water because its density is high. We can choose anything between this, and we can also have some custom range where we can change the mass and we can change the volume also randomly. So because if we change these materials, we have fixed mass upon volume ratio, that is fixed density. But here what we can do, we can change mass and volume randomly or individually, and here we can see how this material is going to do or perform. Here what we can do, we can see at which point this material is completely sink in the water, and using that we can also find out the density of water. We can cross check it because we know it is exactly 1. So you can see, as I am going to do same mass at same volume, so mass upon volume is 1, then you can see this is completely sink, but it is floating on the top, it is not sink below. So if I just increase slightly the mass, then it will go and sink to the bottom. Here you can see the density. Okay, so you don't even need to calculate the density, you can find out it here. So manually you can change this. So what is the glass? Okay, so to find out where is the glass, I will increase the mass. You can see this is shifted to 6.7 kilogram, and now this tab is towards 2.68. Now you can see this human thing is here. Okay, yeah, here is human. So even if you do not know how to swim, then also human, any normal human can swim. I mean, it will not sink in the water. These are order in which the density keeps on increasing, and we will check here the maximum 10 density. So for, if we have density equal to 10, then I have to do the mass must be equal to 10 times than the volume. So it must be, okay, I cannot go beyond 10, so I have to reduce the volume. So I will reduce the volume to 1. So you can see here this comes to 10 kg per liter. So I will slightly increase the volume, and you can get here the copper, so you can get the density of copper. So in this first introduction part, you can have this single material and you can calculate the density. So if you click on this tab, you will see there are two different materials, and now you can see here there are two different dialogues are open. So here also this is A and this is B, and you can change, and you can likewise compare between these two. So because it is a material, fixed material, it has fixed density, so you cannot change both independently or individually. So if I change mass, the volume will automatically change. So again I will change this to custom, and then I will randomly change the volume. So if I increase the volume, at some point it is going to float. Right, so this way we can do this. Then we have this comparison option. We have 5 kg of different materials, and we can change okay. So you can see this B and C have the same mass, but one is floating and one is synced. So we can check for some other materials also. So you can see this is going to float, but other three sink. So we can change the this is for same mass, and A, B, C, D have different densities. Suppose I reduce this mass, then you can see this volume is remaining same, but mass is changed, and therefore you can see, and I can also calculate the volume of this all things, because if I sink this by dragging, you can see here there are 5 liter changes, because if this is not there, there is 100 liter, and if I drop it or if I drag it below, then it is showing 105. So again you can calculate the density, and you can see at which density the material is going to sink. So if I use same volume but different masses, you can see all have different masses, but they are having same volume. So you can see here one is going to sink, one is going to float. So I drop this all. So you can see now their densities are different, but volume is same, and because densities are different, the masses are also different. Suppose I reset this and I am using here same density material, so you can see density of the material is same. So if density is same, let's check whether they will sink or float. So you can see here everything is now floating around, right? Because their density is same. So if there is very heavy machinery and we are trying to find out whether it will sink or not, it will not depend on the mass, it will depend on mass per unit volume, that is the density of that particular matter. So here you can see what is the density. So if I keep on increasing the density, then you can see they are going to sink now. Okay, so I am going to further increase the density. Okay, so they are almost sink in the water. Now it is exactly 1 kg per liter, so it is matching with the density of water. So if I just increase by 1 point, you can see they are going to sink to the bottom. Because there is not much difference in density, they are very slowly sinking. So you can also check that if the density is so much, or there is so much difference in densities of liquid and the material, then that will sink immediately. But if it is not, then it will sink slowly or it will float. So these things you can check on this simulation. Now if we go to the mystery, here what we have to do, we have to wet the material, okay, and then we can drop it to the liquid. So if I drag below this, we can also get what is the volume. So it has volume is equal to 1 liter, and again I will wet here, the weight is 0.4 kg. So we can calculate the density, and you can see this is floating, so it is definitely having density less than 1, and we know it is 0.4 because its weight is 0.4 kg and volume is equal to 1 liter. So this is the one where you have to calculate the densities. Okay, here you can see volume is 5.5. Okay, it is dropped below, so it is dense than water. So you can check it, what is the mass of this. This mass is almost 20 kg and the volume was 5, around 5. So it is almost 3 times more. So it is, you can calculate the density. Similarly, we can do this for all of this, or we can do this together. Now we have set 2, so there are just random things so that you can check it. So you can see here, if I drop this, okay, so they have different density materials, right? You can see here, one is sink to the bottom, one is floating on the top, and one is almost synced but not totally synced. So they have different densities, so you can compare things, and on the last tab you can check what to do. So these are random, so they are not specifically have same mass or same density, so they have some variations. So you can see, and you can again refresh this at any point. So this will show you how the material will behave if it has particular density. Now if I click on this density table, they are giving us the material and their densities in kg per liter. So you can check this. For such interesting videos, click the subscribe button, like this and share with your friends so that they will also get benefit out of it. Thank you for watching. Have a happy learning.